so we know this x-axis is your bonding energy, and it's going in decreasing energy, right? Decreasing. We already knew that. But my new question I'm going to pose to you is, what kind of electrons, that's what these peaks are, the number of electrons, number of E relative, would require close to 1,000 megajoules of energy per mole. Yikes. Well, those electrons really not want to leave this atom. So those are your core electrons. The ones, not just your core, but the ones closest to the nucleus. In other words, they're your 1s orbital. You already knew that. And these are your valence electrons, because look how much little energy they require. They're all the way out there, far from what they're attracted to is the nucleus, the nuclear charge, the Z. Okay, I tried to put a twist. Let's do it. So you know this is going to be your, come on, when did I circle that? There you go. You know this is going to be your 1s orbital, because in order to get here, in order to get to the energy levels that are orbitals that are farther away, we've got to follow Aufbau. This is your 1s orbital. You know, they can hold 2 electrons. You can mark that off with 2 if you want. You know, 2s is next. You know, 2p is next. These have to fill before you get over here. You know this is 6 electrons. Got to have 6 electrons in your 2p before you have anything else later. You can mark that off if it helps. That's 1, that's 2, that's 3, 4, 5, in case you get some weird height in between here. But you don't. All right, what's next? 3s. What's next? 3p. All right, makes sense. Now, what's after 3p? Did you say 3d? Hold on. Finally, something different. So now we need to wonder, is that your 4s, which would be Aufbau? Or is that your 3d? And we're not given, this is a great question, because we're not given much, we're not given away by, if this had a peak of like 10, we would know it's just automatically your 3d, but it's not, because the peaks are just 1s and 2s. That one has 1 electron, that one has 2. So it could be either one of these, because the s's hold 2 and the d's hold 10, so it could be either one. Now, this is kind of giving away what we're going to learn next, actually, is in our next lab. When you fill, you've got to fill following Aufbau. And Aufbau says you fill 4s and then you fill 3d. But this is not an Aufbau filling. This is rather a photoelectron spectroscopy. And one of the most valuable techniques we have in practicality to see what the structure of atoms look like. And so what this equipment does is, you have electrons in some arbitrary orbital. You have to put some energy, right? Planck's constant times mu. And only if you have enough energy, then will you get these electrons ejecting with some amount of kinetic energy, which this equipment will detect. My point is, this is a graph of removing electrons, not filling electrons. Aufbau is filling. Removing, you don't follow Aufbau. Let me say that again. When you're removing electrons, you remove from the highest n first. When you fill the let me get this right. You fill following Aufbau, which says you fill 4s before 3d. But when you remove, you don't just go backwards. You don't remove 3d first and then you remove the 4s's first, or there are 5s's or 6. The highest n gets removed first. They get filled here first, and then they get removed first. They're just first. So go ahead, pause if that helps at all, and figure out which of these peaks is which. Okay. Well, this I just told you. So that right there is your 4s. Because when you remove, this is a removing graph, PES graph plots, those 2 electrons there are coming out of your 4s. And then your 3D electrons are coming out. So this is going to be a scandium because that element ends in the 4s1. I'm sorry, the 3d1. Here's your 3D block. This is the first. It's 21. You can count these electrons. There's your answer, scandium.